So we're going to continue on with algebra. I'm just going to do a quick bit of revision. If I said to you 3 lots of 78, and if I asked you to do that without a calculator, just, to work it out, the easiest way I know to do that is to go 3 lots of 70 plus 3 lots of 8. So here's my 3 lots of 70, which is 210, and here's my 3 lots of 8, which is 24. So I know that 3 lots of 78 is 210 plus 24, which is 234. Much easier than trying to do vertical multiplication and carrying and so on. That's the sort of thing you could almost do in your head. So 3 lots of 78 is actually 3 lots of 70 plus 3 lots of 8. 3 lots of 70 plus 3 lots of 8. We can take that one step further and make it algebra and say, well, what's 3 lots of any number plus 8? So my any number I'm going to write as x, and I'm going to see what that expands to. So 3 times x I write as 3x. 3 times 8 is 24. So 3x plus 8 is going to be, 3 lots of x plus 8 I should say, is going to be 3x plus 24. It's how you go from a multiply to an add. Sorry about that. Now let's look at a little bit more complicated example. So let's have a look at a bit more complicated example, maybe 2-digit multiplication. And I've got 13 times 78. So I'm going to break up my 13 into a 10 and a 3, because 10s and 3s are really easy to multiply. And I've got 70 and 8. Well, 70 times 10 is 700. And 10 times 8 is 80. And here I've got 3 lots of 70, which we know is 210. And in this last one I've got 3 lots of 8, which is 24. So I know that 13 times 78 equals 700 plus 210 plus 80 plus 24, which gives me a total of 290, 990, 1,000, 1,014. So the hardest thing I had to do when multiplying two two-digit numbers is actually add them up at the end. And if you notice, these are hundreds, these are ones, and these are both tens, because 8 times 10 gives me tens, and 3 times 10 gives me tens. Tens times tens gives me hundreds, and ones times ones gives me ones. That's important for when you look at these next example, x plus 3 times x plus 8. So any number plus 3 times any number plus 8. Let's have a look what that becomes. So I've got my first box. I've got x times x gives me x squared. So x times x we write as x squared. In this box I've got 8x, because I've got x times 8, which we write as 8x. In this box I've got 3 times x, which we write as 3x. 3, is it? That's better. 3x. And here I've got 3 ones times 8 ones is 24. So when I actually work that out, the answer to that is x squared plus 8x plus 3x plus 24. Now the only ones that I can simplify there are the 8x and the 3x. So my actual answer is x squared plus 11x. 8 and 3 is 11. So 8 lots of x plus 3 lots of x is 11x. Plus 24. Now that comes from, if you look at it, here is the x squared, x times x. Here is 8x, x times 8x. Here is 3x, 3 times x. And the last one is 3 lots of 24. So you may have seen that as first, outside, inside, last. But that's the picture that goes with it. And remember, you can only ever add like terms, ones that are the same. So x squareds can be added to x squareds, x's can be added to x's, and numbers can be added to numbers. But this cannot be simplified anymore. X squared plus 11x plus 24. And if you remember the game we played, what two numbers multiply to give you 24 that add to give you 11? That's 8 and 3. 8 and 3 is 11, 3 8s are 24. Let's have a look at two special cases now. A difference of 2 squares is the first one. So, once upon a time they didn't have calculators, and to do something like 20 squared minus 15 squared would have been quite tricky. So, 20 squared, 2 2s are 4, 10 squared is 100, so that's 400. 15 squared is 10 plus 5 times 10 plus 5, which is 10 10s are 100, 10 5s are 50, 5 10s are 50, and 5 5s are 25. So that's 100, 200 and 25. So the difference between those two is 400 minus 225, which is 175. Now let's have a look for the pattern. If I did 20 plus 15 and 20 minus 15, what would I actually get? Well, 20 plus 15 is 35 times 20 minus 15 is 5. So what's 35 times 5? 150 plus 25. That actually is 175. So you could have either said to yourself, 35 doubled is 70. So 4 lots of 35 is going to be 140, and one more lot is 175. Or you could have done 5 lots of 30 plus 5 lots of 25. 5 lots of 30 being 150, 5 lots of 5 being 175. So to work out something that appeared quite tricky in the beginning, 20 squared minus 15 squared, what I can actually do is 20 plus 15, 20 minus 15. And that one is called a difference of 2 squares. So if you've got a number and you've got another number, you've got to find the difference. So we've got, let me just make a thing here, a squared minus b squared. So a is your bigger number and b is your littler number. So here I've got 20 and 15. That equals a plus b, a minus b, every single time. And that's just the way the pattern works. The next one is perfect squares. So this one is not a rectangle, but a square. So here, for instance, I've got x plus 7 all squared. So x plus 7 times x plus 7, or x plus 7 all squared. So you can see that that's x squared plus 7x plus 7x plus 49. So x times x is x squared. X times 7 is 7x. 7 times x is 7x. And 7 7s are 49 as well. And if you had have done it the short way, you would have done x squared plus 7x plus 7x plus 14. And that happens to be the rule. So let me write that down. X squared plus... I'm going to just add these two together because I can. They're both x terms. So I've got 14x plus 49. And if you look at the pattern that comes from that, well, it's the first term squared, it's the last term squared, and it's 2 times x times 7 in the middle, because that's where I had this rectangle and this rectangle. So it's 2 times x times plus 7, which is 2 lots of x times 7, or 14x. So the general rule for that one is a plus b all squared is a squared plus 2 lots of ab plus b squared. The first term squared, the last term squared, plus 2 lots of the product. 2 lots of the product every single time. The last one we're going to look at is expanding 3 brackets. So let's look at an easier example first. If I've got 3 numbers to multiply together, does it matter which way I multiply them, which order? Could I do 3 times 2, which is 6, times 5, which is 30? Or I could do 2 times 5, which is 10, times 3, which is 30. Or I could do 13 times 5, which is 15. Double that, I'd get 30 as well. So I only ever multiply the other numbers once. So I don't so that's 3 times 2 times 5 once over. It's the same with brackets that look like this. So these 3 brackets mean that it's a cubic function. I'll get a cubic function because there'll be an x cubed. That's actually a volume, not an area. So when you've got 2 brackets, it's an area, it's 2 dimensions. This has got 3 dimensions, so it's a volume question. So, for example, I might expand the first bracket out. I'd get x squared plus 5x plus 3x plus 15. So I've got x squared plus 5x plus 3x plus 15. And that all has to be multiplied by x plus 2. So let's tidy this one up first. I've got x squared plus 8x plus 15, all multiplied by x plus 2. So let's have a look what happens now. I've got to multiply every term in this first bracket by every term in this second bracket. So x squared times x gives me my x cubed function, plus x squared times 2 is 2x squareds, plus, that was that one, plus 8x times x, which is 8x squared, plus 8x times 2, which is 16x, plus 15 times x, which is 15x, plus 15 times 2, which is 30. And now I go and I look and I say, okay, which ones can I simplify there? Well, there's only one x cubed term. Let's have a look for x squareds. Well, there's my x squareds. So 2x squared plus 8x squared is 10x squared. 16x plus 15x is 31x, and the last one is 30. So remember, when you've expanded 3 brackets, you expand if there's a pattern there that you can use, a difference of two squares or a perfect square, something that you recognise, do that first. If not, just expand out 2 brackets and then multiply everything in that by the 3rd bracket. And you can't go wrong.